In this section, we will use Python's built-in open function to create a file object and obtain the data from a txt file. We will use Python's open function to get a file object. We can apply a method to that object to read data from the file. We can open the file example1.txt as follows. We use the open function. The first argument is the file path. This is made up of the file name and the file directory. The second parameter is the mode. Common values used include R for reading, W for writing, and A for appending. We will use R for reading. Finally, we have the file object. We can now use the file object to obtain information about the file. We can use the data attribute name to get the name of the file. The result is a string that contains the name of the file. We can see what mode the object is in using the data attribute mode, and R is shown representing read. You should always close the file object using the method close. This may get tedious sometimes, so let's use the with statement. Using a with statement to open the file is better practice because it automatically closes the file. The code will run everything in the indent block, then closes the file. This code reads the file example1.txt. We can use the file object file1. The code will perform all operations in the indent block, then close the file at the end of the indent. The method read stores the values of the file in the variable file_stuff as a string. You can print the file content. You can check if the file content is closed, but you cannot read from it outside the indent. But you can print the file content outside the indent as well. We can print the file content. We will see the following. When we examine the raw string, we will see the /n. This is so Python knows to start a new line. We can output every line as an element in a list using the method readLine. The first line corresponds to the first element in the list. The second line corresponds to the second element in the list, and so on. We can use the method readLine to read the first line of the file. If we run this command, it will store the first line in the variable file_stuff, then print the first line. We can use the method readLine twice. The first time it's called, it will save the first line in the variable file_stuff, and then print the first line. The second time it's called, it will save the second line in the variable file_stuff, and then print the second line. We can use a loop to print out each line individually as follows. Let's represent every character in a string as a grid. We can specify the number of characters we would like to read from a string as an argument to the method readLine. When we use a 4 as an argument in the method readLine, we print out the first 4 characters in the file. Each time we call the method, we will progress through the text. If we call the method with the argument 16, the first 16 characters are printed out and then the new line. If we call the method a second time, the next 5 characters are printed out. Finally, if we call the method the last time with the argument 9, the last 9 characters are printed out. Check out the labs for more examples of methods and other file types. We can also write to files using the open function. We will use Python's open function to get a file object to create a text file. We can apply method write to write data to that file. As a result, text will be written to the file. We can create the file example2.txt as follows. We use the open function. The first argument is the file path. This is made up of the file name. If you have that file in your directory, it will be overwritten, and the file directory. We set the mode parameter to W for writing. Finally, we have the file object. As before, we use the with statement. The code will run everything in the indent block, then close the file. We create the file object file1. We use the open function. This creates a file example2.txt in your directory. We use the method write to write data into the file. The argument is the text we would like input into the file. If we use the write method successively, each time it's called, it will write to the file. The first time it is called, we will write this is line A with a /n to represent a new line. The second time we call the method, it will write this is line B, then it will close the file. We can write each element in a list to a file. As before, we use a with command and the open function to create a file. The list lines has 3 elements consisting of text. We use a for loop to read each element of the first lines and pass it to the variable line. The first iteration of the file. The first iteration copies the first line. The second iteration copies the closed.
Dependencies or libraries are pre-written code to help solve problems. In this video, we will introduce Pandas, a popular library for data analysis. You can import the library or dependency, like Pandas, using the following command. Start with the import command followed by the name of the library. You now have access to a large number of pre-built classes and functions. This assumes the library is installed. In our lab environment, all the necessary libraries are installed. Let us say we would like to load a CSV file using Pandas' built-in function, read CSV. A CSV is a typical file type used to store data. Simply type the word pandas, then a dot, and the name of the function with all the inputs. Typing pandas all the time may get difficult, so you can use the as statement to shorten the name of the library. In this case, use the standard abbreviation PD. Now type PD, next type a dot followed by the name of the function you would like to use. In this case, read CSV. You are not limited to the abbreviation PD. In this case, we use the term banana. However, we will stick with PD for the rest of this video. Let us examine this code in more detail. One way Pandas allows you to work with data is in a data frame. Let us review the process of going from a CSV file to a data frame. This variable stores the path of the CSV. It is used as an argument to the read CSV function. The result is stored to the variable df. This is short for data frame. Now that you have the data in a data frame, you can work with it. You can use the method head to examine the first 5 rows of a data frame. The process for loading an Excel file is similar. Use the path of the Excel file, the function read Excel. The result is a data frame. A data frame is comprised of rows and columns. You can create a data frame out of a dictionary. The keys correspond to the column labels. The values are lists corresponding to the rows. You can then cast the dictionary to a data frame using the function dataFrame. Notice the direct correspondence between the table. The keys correspond to the table headers. The values are lists corresponding to the rows. Create a new data frame consisting of one column. Enclose the data frame name, in this case df, and the name of the column header in double brackets. The result is a new data frame comprised of the original column. You can do the same thing for multiple columns. Enclose the data frame name, in this case df, and the name of multiple column headers in double brackets. The result is a new data frame comprised of the specified columns. One way to access unique elements is with the iloc method. The first input is an integer representing the row index, and the second is the integer representing the column index. You can access the first row and first column as follows. You can access the second row and first column as follows. You can access the first row, third column as follows, and you can access the second row, third column as follows. You can use the name of the row index and the column as well. You can access the first row of the column named artist as follows. Similarly, you can access the second row of the column named artist. You can do the same for the column released. Lock can also be used if the index is not an integer. We create a new data frame called dfNew. We replace the index 1, 2, 3, and so on with ABC. You can access the index A, that is, the first row of the column named artist, as follows. Similarly, you can access the index B, or the second row of the column named artist. You can do the same for the column released. You can also slice data frames and assign the values to a new data frame. Assign the first 2 rows and the first 3 columns to the variable z. The result is a data frame comprised of the selected rows and columns. You can also slice data frames and assign the values to a new data frame using lock. The code assigns the first 3 rows and all columns in between the columns named artist and released. The result is a new data frame z with the corresponding values. Check out the labs for more examples.
When we have a data frame, we can work with the data and save the results in other formats. Consider the stack of 13 blocks of different colors. We can see there are 3 unique colors. Let's say you would like to find out how many unique elements are in a column of a data frame. This may be much more difficult because instead of 13 elements, you may have millions. Pandas has the method unique to determine the unique elements in a column of a data frame. Let's say we would like to determine the unique year of the albums in the data set. We enter the name of the data frame, then enter the name of the column released within brackets. Then we apply the method unique. The result is all of the unique elements in the column released. Let's say we would like to create a new database consisting of songs from the 1980s and after. We can look at the column released for songs made after 1979, then select the corresponding rows. We can accomplish this within one line of code in Pandas, but let's break up the steps. We can use the inequality operators for the entire data frame in Pandas. The result is a series of Boolean values. For our case, we simply specify the column released and the inequality for the albums after 1979. The result is a series of Boolean values. The result is true when the condition is true and false otherwise. We can select the specified columns in one line. We simply use the data frame's names, and in square brackets we place the previously mentioned inequality and assign it to the variable df1. We now have a new data frame, where each album was released after 1979. We can save the new data frame using the method to_CSV. The argument is the name of the CSV file. Make sure you include a .csv extension. There are other functions to save the data frame in other formats. In this video, we will be covering NumPy in 1D.